Okay, hi, welcome. Let's do some vector questions with me just to revise. Okay, so we're just going to focus on vectors today. Okay, let's go to question 1. In a computer network, data packets are transmitted between two non-parallel routes represented by vectors r and s. So we have r and s over here. The total data flow across these routes is balanced. Okay, resultant vector is 0. The weights of the data flow along the routes are modeled by the equation 3a minus b plus 5r plus 4a plus 2b minus 6s equals 0. Okay, so calculate the values of a and b. Okay, so since they're non-zero and non-parallel, what we're going to do is we're just going to set it to 0. So it's going to be something like this. 3a minus b plus 5 equals to 0. Don't take into account for r. Okay, so because we have this, it is equal to 0. We are literally setting it as 0. Okay, then what we're going to do is we're going to make b the subject. Sure, why not? B equals to 3a plus 5. Okay, so this would be the first equation. Okay, and then for equation 2, we're going to do the same thing. 4a plus 2b minus 6. Do not take into account for s. Okay, 0. Okay, now what I want to do is, the reason why I set b as a subject here is because I just want to substitute it into here in order to find what exactly is a. Basically, what's happening right now is we are doing substitution. Yeah, we're doing substitution. Okay, so when I substitute it into into b, it's going to be 4a plus 2, 3a plus 5 minus 6 equals to 0. Yeah, so it's going to be 4a plus 6a plus 10 minus 6, right? Okay, it's going to be 10a plus 4 equals to 0. Okay, yada yada yada. 10a equals to negative 4a equals to negative 4 over 10, negative 2 over 5. So now we already have our a. So since we already have our a, then we can calculate our b. So from here, we can just, substitute it back into here. Alright, so let's actually do that. Okay, so I'm going to use a different color to show it. Okay, then I go here into here. So b is going to be 3 times what, negative 2 over 5, right? Okay, plus 5. So it's going to be negative 6 over 5 plus 25 over 5. Is it? Yeah, I guess. Okay, so it's going to be 19 over 5. Okay, so that is the answer. So the final answer would be a equals to negative 2 over 5, and then b equals to 19 over 5. Okay, that is for question 1. What is the 5 over there? Okay, let's move on to question b. Okay, so diagram 1 shows triangle EFH, and G is the point on the line FH. Okay, so given EF equals to 5P, EH equals to 10Q, and FG equals to 4GH, blah blah blah. Okay, so first of all, when we encounter a question like this, the best practice is for you to extract the information and write it down on the question immediately, so you know how to determine what is what without having to look back and read the whole sentence again. So okay, EF would be 5P, and then EH would be 10Q. Okay, so then FG equals to 4H. Okay, so I'm guessing FG and GH has like 4:1 ratio. FG equals to 4GH. So yeah, so 4 FGs, 4 and then 1, because 1 FG is equal to 4GH. Okay, faham. Okay, next, okay, what is the first question? Find FH. So we're gonna have to find F2H. Oh, okay. Okay, we can just use FE plus EH then, because I don't want to use the FGH thing. We don't have that information yet. So first, I'm just going to write down FE plus EH. Okay, so why did I take FE? I can just go here and go here, which is basically the same as FH. But when we flip a vector, then you still need to flip the positivity, the negativity of said equation. Okay, so since EF is positive 5p, then FE would be negative 5p. Okay, plus EH equals to 10q. So yeah, that is the answer for FH. FH equals to, let's do this. Yeah, okay, that's that. Okay, now for EG, of course they will ask EG. Okay, so now for EG, since FG equals to 4GH, which means G divides FH into 5 parts. So there's like 5 parts. I can't really draw it for you, but there's 5 parts here in total. So that means FG would be 4/5 because it takes 4 steps here. Okay, so it's going to be 4/5 of FH. Why FH? Because it's the whole thing. So basically what I'm trying to say is, this is FH, right? Right now, FG takes up only this part, which is 4/5. Okay, so that is how it works. Okay, so now, since we already have that information, FG. Okay, since we already have the information, what we're gonna do is we need to find EG. EG, I think I can use EG equals to EF plus FG. Yeah, let's do that. Okay, so EF plus FG. Okay, so earlier I found that FG is 4/5 of FH and FH, which is over here. So yes, we have all the information that is required. So let's just add everything up. EF would be 5p, and then FG would be 4/5 of FH, which is 10q minus 5p. And so the answer would be 5p plus 8q minus 4p. So it is p plus 8q. Okay, that is the answer for B. Okay, now for C. In a three-dimensional space, the vectors A equals to x minus y plus z, B equals to 2x minus 4y plus 2z, and C 3x minus y plus 3z are expressed in terms x, y, and z, which represent scalar components along the respective axes. So you know how the x, y, z axis works, like x, y, and then we like this z is like in the middle or here, I don't know. Yeah, same thing. It's just basically in between of x and y. Okay, calculate the coefficient b plus c in terms of x, y, and z. Simplify your expression. Okay, so basically just add b and c. That is what this question wants. So b plus c equals to 2x minus 4y plus 2z plus 3x minus y plus 3z. So that is 5x minus 5y plus 5z. Okay, so we can simplify that. We can simplify that into 5 times x minus y plus z. Okay, so since if you notice, this is x minus y plus z, this is also x minus y plus z. So basically this is actually 5a, which means B plus C is the scalar multiple of A. And if we look at what scalar multiple is, it's basically lambda times whatever is here. So that's going to be like 5 is the lambda, and then whatever is here is A, because it is this one. It is this. So yeah, that is how scalar vectors work. Okay, let's just move on to the next question. Okay, prove the following statements. The vectors A and B plus C are parallel. Okay, this is what I mentioned earlier. Verify this by showing B plus C is a scalar multiple of A. So this is what I said earlier. Lambda and whatever. So earlier we have 5x plus y. X minus y. X minus y plus z. And we do know x minus y plus z is A. So that would be 5A. But we have to write it in a proper method. So how am I going to write it? I'm going to write it like this. B plus C equals to 5x minus y plus z. Okay, therefore, B plus C equals to 5A. Or you don't need to put the brackets pun okay je. So 5A. So that is your answer here. Okay, the magnitude of B plus C is 5 times the magnitude of A. Okay. Oh, we have to prove that. Okay, fine. Okay, prove the... Oh, okay. I think this is supposed to be simple. B plus C... 5A. 5A? Literally. Yeah, because the magnitude of A is literally magnitude of A. Okay. This is literally the magnitude of A. So since B plus C is, 5 times the magnitude of A, just 5 times this. Basically just that. Okay. Now let's do D. Okay. Consider the vectors P plus, equals 5U plus 3V minus 2W. Q equals to negative SU minus 4V minus TW, and R equals to S plus 1U minus V plus T minus 6W, where S and T's are constant. Okay, if P plus Q equals to R, determine the numerical values of S and T. Okay, so basically, let's just add on first, P and Q. Is there space on here? Okay, I'll do it down here. Okay, P plus Q. So P is 5U plus 3V minus 2W, and then Q is negative SU minus 4V minus TW. So how am I supposed to add all this when there's so many unknown variables? So what we're going to do first is I'm just going to combine the numbers of the unknown variables. So it's going to look something like this. 5 minus S. So this one is for U. And then and we have plus 3 minus 4. This is for V, and then minus, oh no, let's do plus. Negative 2 minus T. W. Yeah, because when I take it out of the bracket, it's going to be negative anyway. Okay, so it's going to look something like this. Okay. Let me recheck everything. Okay, yeah, there 3 minus 4, that's going to be negative 1, right? So negative 1, I can just write it as negative V plus negative 2 minus TW. Okay, now, since in the question it did say P plus Q equals to R, so we can basically equate all of this as R. So how exactly does that work? Let me write this down for you. 5 minus S U minus V plus minus 2 minus T W equals to, okay, R is S plus 1 U minus V plus T minus 6 W. Okay, so now that we've already equate both of them, then let's just samakan the things. Okay, so this is for U. Okay, V memang negatif 1 lah. Okay, so this is for W. Okay, Therefore, for u, we have, no, I'll do this. U is 5 minus s equals to s plus 1. Yes. So, yada yada, that's going to be 4, 2s, s equals to 2. Okay, now for w, negative 2, negative t equals to t minus 6. Okay, so yada yada, it's going to be 4 and then 2t. T is also equals to 2. Okay, so now we've already determined what are s and t. Okay, so now let's move on to the second one. Okay, hence calculate a unit vector indicated in the direction of q. Okay, unit vector. Unit vector, the equation is gonna be something like this, I think. It's gonna be the normal equation and then the magnitude. Yeah, I think that's the equation. Okay, so let's first calculate its magnitude of q. So calculating magnitude requires square root. Okay, so let's do from q is, oh right, okay, since s is 2 and then this is also 2, so we basically just gonna put negative 2 squared plus negative 4 squared plus negative 2 squared. Okay, and then we're just gonna square root all that. Okay, wait, 4, 16, 4. Okay, square root 24. What is that? Hold on, square root 24. Okay, 2 third 6. Just write it properly. I'm writing it this way because I don't really have space for the next question, I think. Okay, let me just put this here. Oh wait, no. Okay, tak apa. Okay, so that is the magnitude. So now let's find the unit vector. So unit vector has this kind of symbol, this arrow thing. So it's going to be the original vector over the magnitude. So I'm just going to put in negative 2u, right, negative 2u minus 4v minus 2w. So that's going to be over 2 third 6. Okay, so this looks like you can simplify it more. So I'm just going to simplify it. So negative 2 over 2 third 6. So 2 divided by 2 is going to be 1. Yeah, u. And then we have 4 over 2, that's just going to be 2. 2 over v, okay. Then 2 over 2, okay, 1 sama juga w. Okay, so that is the unit vector of q in the direction of q. Okay, so now for the third question, find a vector of magnitude 6 units in the direction of q. So basically, when they say whatever unit in the direction of a vector, you just need to calculate. You just need to multiply the unit vector with the set units. So in this case, I'll write this here. Okay, so in this case, it's going to be, the magnitude is 6 multiplied by unit vector of q. So it is 6 times u 2 over 6v 1 over 6w. So 6 times the denominator is just gonna get negative u, negative 2v, negative w. So this is what happens when you times the unit vector with the magnitude here, which is 6. So yeah, that is, I'm not going to go into differentiation. So that is for set A. Okay. I'll be back to proceed with set B.